In games like Hearthstone or Slay the Spire, you often have the situation that card effects trigger other card effects, and those effects chain together, triggering more effects. In this video, I will teach you how to create an action and reaction system that works really well with card games and how to set up an architecture around the system for your card game. This system and architecture is the starting point for most of my card games. The system allows our cards to react to other cards and keeps our reaction chain clean so that all our actions perform in the right order. Before I show you how the system works, I want to give an example scenario that the system should be capable of. Imagine that in a card game, you play a card that draws you one card. On the field, you have a minion that deals 3 damage to the enemy whenever you draw a card. And to make the scenario a bit more challenging and complex, and to show you what our system is capable of, we also have a minion that gets a stat increase of +1/+1 for each damage that was dealt to the enemy hero. So when we deal 3 damage, the minion receives +3/+3. That's our scenario. And here is how we will make it possible with our system. Every effect we have will be a game action. This is one of the key parts of the system. In a game like Hearthstone, for example, almost everything would be a game action. Turn changes, damage, card draw, summoning minions, all those things would be separate game actions. The game action holds all relevant data that is needed to perform the action. So for example, damage action would have the damage amount and a target. Then we have the action system. The action system is responsible for performing actions and reactions. Whenever a game action is performed, this system checks if there are any reactions to this type of game action. Those are then performed. And because those reactions are also game actions and also are performed by the action system also makes sure to check if there are any chained reactions to those previous reactions. The action system resolves all of this until all actions and reactions were performed. I could tell you more about how the system works in detail, but I guess it makes more sense to see it in a code. First, we have our abstract game action class. It has 3 lists of reactions. We need those so that we can store all reactions that occur while this particular action is performed. This way, we can go down the list in a tree-like structure later and perform all reactions in the right order. You don't need to understand how it works now because I will show it to you later in the action system. We have 3 lists because we will have reactions that should happen before a game action, during a game action, and after a game action. How to make implementations of your game actions I will show you later. The second part and core of our action system is the action system. Here we have a lot of things going on, but when finished you can reuse the action system for a lot of things, and when ready it can stay as it is for most of your projects. And even if you don't understand some things that are going on here, no problem. Once finished, you will just use a few simple methods from it and never touch the action system class again. The action system is a singleton. If you don't know what a singleton is and how to make one, watch my video about singletons. You will find the link in the description. Inside the class, we have a reference to the current reaction list. Here we will reference the lists that are inside our game actions. We always want to reference the list of the current phase here so that the reactions can be added. It will make a bit more sense later. We also have a property isPerforming. This is nice to have when you want to only allow interactions with cards, for example, when the system is not performing. Then we have 3 static dictionaries: the pre-subs, post-subs, and performers. The pre-subs are all reaction subscribers that subscribed to the pre-phase of our game action. What I mean by this is that when you draw a card, you can have a reaction to the draw card action that triggers before the card is drawn. Post-subs are the same, but for the reactions that trigger after a game action. Performers hold the logic for game actions. In our game actions, we don't have any perform logic, but only data. For each game action type, we attach a performer that is called when the action system performs a game action of this type. You will see it later in action. To fill those lists with reactions and performers, we have a few methods. Those methods are static so that they are always available, and this will work similar to how an event system works. We can subscribe and unsubscribe with reactions and performers. Here is how those methods look like. In attach performer, you will pass over a method with a enumerator return type and t parameter, where t is a game action. This method is the performer. It does the logic of our game action. It's an enumerator because we sometimes want to wait while the logic is performed. Inside the method, we add it to our dictionary. We first get the type, then we convert our performer so that it can be added to our dictionary, then we add it. And the detach method detaches the performer and works similar. Per game action type, you can only have one performer. I will show you later how those performers look like and how they work. For reactions, we have the subscribe reaction and unsubscribe reaction methods that subscribe and unsubscribe reactions to a type of game action. We also pass a reaction timing here. With the timing, you can tell if you want a reaction to happen before or after a game action. Inside the methods, we do something similar to what we did in attach performer and detach performer. Remember, we can have multiple reactions to one game action type. I will also show you later how reactions look like. Then we have the perform method. This performs an action. For this, we give it an action and an optional callback that is called when perform is done. Inside, we return when we are performing so that we only can run this method when no other action is performing. We then set the is performing to true and start a coroutine with the flow. When the flow is done, we set is performing to false and call the callback. In the flow method, we first set the reactions to the pre-reactions list of our current action. Now all objects in our game can react to the current action's pre-phase. If there are reactions, those can be added to this list. We then call the perform subscribers method for our pre-subs list. This method tells all pre-subscribers of this game action type that we currently are performing this game action, or better said, that we are in the pre-phase. Those subscribers then have the time to react and to add a reaction. For this, we will later need this reaction method, which just gives you the ability to add reactions from other classes. It always adds the reactions to the current list. Then, back in the flow, we perform all those reactions. Here you can see that for each reaction we call another flow method. So for each reaction we will call the whole process again until there are no more reactions to resolve. Back in the flow, everything that happened before we have performed the performer of our action. So those were the pre-reactions. Then we finally perform our performer. Before we do this, we change the reactions list to the performer reactions list. You won't have reactions here as often, but sometimes a performer will do some stuff and also add its own reactions. In this case, we need this here. After the performer, we perform the reactions. Like I said, most games won't need it, but if you ever have this case, you will be happy to have it already implemented here. Then we go to the post reactions and do the same we did for the pre-reactions. At the end, we call our callback. It may have been a bit complicated, but that's it. That's all you need for the system. Now I will show you how to use it and how powerful it is. In our scene, I have prepared a few things. The knife that will damage the health after a card is drawn, a minion that will get +1/+1 for each damage dealt, and a card that we can use by clicking it. How the damaging or the drawing exactly works is not that important. Important is how we connect those to our action system. For this, we will have two types of methods in our code. The performer, which has to look like this, and the reaction that has to follow this structure. The performer will perform the logic for the draw card action, and the reaction will do something when a card is drawn. So let's create our game actions first. Like we said in the beginning, we will have three different game actions here. Draw card, deal damage, and increase stats. Like I already said, they just contain the data. In a real game, you could have more insight, like a target for the damage or amount of cards drawn, but for this tutorial we will keep it simple. To make the best use of our action system, I recommend a special architecture. It's a system-based architecture. In this architecture, everything in your game has an own system. A card system is responsible for drawing cards and keeps track of all cards you have in your hand. All performers that perform card-related game actions are in this system. A damage system handles all the damaging. Why is this good? Because with this approach it doesn't matter if a card did the damage or a minion, the damage is handled the same way. And that is exactly what we want to achieve in a card game. We can have a stat system that handles stats, a minion system that handles minions, and many more systems. And in the end, it's up to you. There are no exact rules for this. In one of my projects, I even had a draw card system that only was responsible for drawing cards. Sometimes it's good to make things modular. Let's implement the card draw first. Here in our card script, when the card is clicked, we first check if the action system is performing. If it is, we return. This way we can only interact with the card when no action is performing. We then create our draw card game action and give it to the action system with perform. Now the action system starts performing. We also destroy the card here. We then need a performer for this action, and here is where our systems come into play. For this I have a card system script. Here we have the performer that performs the draw card method. It is an IEnumerator and has the draw card game action as parameter. Inside, we just instantiate the card and move it to the right position in our hand. For moving stuff around, I use doTween, by the way. That's the whole performer. In this case, we had no data inside the draw card game action, so we didn't use it here. We have to attach the performer to the action system in the enable and detach it in the disable method. That's it. We can try out our code. When we click the card, it is destroyed and we draw another card. Cool. Now let's add our first reaction. So whenever we draw a card, we want to deal 3 damage to the health. The reaction comes from the knife, because the knife is the object that wants that the damage is dealt. For this, we add a draw card reaction in our knife class. It returns nothing and has the draw card game action as parameter. Inside of reaction methods, you always should only chain other game actions to the action system. Remember that we want our functionality to be consistent and be only triggered within the performer in our systems. So inside of all your reaction methods, just create a new game action and add it with the add reaction method. We also have to subscribe and unsubscribe the reaction. Here we will also use the reaction timing. We want to deal the damage after the card was drawn, so post. If you want the reaction to trigger before the card draw, then pre. At the moment we don't have a performer for the deal damage game action. So let's create one inside the damage system class. Here you can see that we read the damage value that we have set in our damage action. We can take this value and do that much damage. The rest is just some animation stuff. In a real game, you would also store the target for the damage in the game action, but let's keep it simple in this tutorial as we only have one target, the health. You may ask, Why do we create a separate performer instead of just dealing the damage in the reaction? It's because we may want to deal damage not only as reaction to draw card, but also to other things in the future, and maybe not even as reaction, and not only by the knife class. That's why we have performers for all of our actions. Also, don't forget to attach our performer to our deal damage action in the enable and to detach it in the disable method. Make sure everything is in your scene and then you can test it out. When we click on the card, first the card is drawn, then the knife reacts and attacks the health. Cool, huh? You can also play with the reaction timing and change it to pre. This way the damage is dealt first before the card is drawn. Look how easy it is to connect things. The same for increasing stats. In our minion class we have a few methods to actually increase the stats, but those are not the performers. Remember that. We may have many minions later, but only one performer, and that's why we will have the performer in a system. But first we add the reaction here. The minion should react to the damage dealt and add some stats. So make a reaction method and subscribe it to the action system. Inside, create an increase stats game action. And here you can see a cool thing. In the increase stats game action, we also pass a target. In this case, the target for the stat increase is this minion, so we pass this as a first parameter. Because this is a reaction to deal damage, we also have the deal damage game action as parameter in this method. This way, we can take the damage that was dealt from the deal damage game action and use it as the stat increase. Can you see how this changes all together? You could now even have a reaction to the deal damage game action that triggers before the damage and that changes the damage of the game action. This way you can even manipulate game actions. Now add the reaction to the action system and let's move on to our stat system to implement the performer. In the stat system we take the attack and health from the game action and we also take the target. We then call a method on the target and give it the stats. Also attach and detach the performer inside enable and disable. Now run the game again and you can see how everything changes together. We draw a card, then we deal 3 damage, and because we have dealt 3 damage, the minion gets +3/+3. Great! This is just an example how the architecture looks like. I'm working on some more tutorials to show a framework for a card game from scratch using this action system and this system-based architecture. I hope you liked this video. If you did, please leave a like and a sub, it helps me a lot. Thank you for watching and see you next time.